let's get started. So system of equations in two variables. So a system of linear equations, these are all linear, and their solutions. So a system of linear equations occurs simultaneously and they have the same variable. So here we have x and x and y. So here we have, this is a system of two equations in two variables. That's what we're going to be doing in this one. And so they have the same variables in this, and they occur at the same time. So that's what this little bracket means. It means both of these occur at the same time. A solution is an ordered set. So here we have an ordered set that satisfies the equation, aka makes them true. And so let's start there. So I'm always going to call this one equation 1 and equation 2. So this is one that's terrible. This is 1. This is 2. You only know it because I say it. And so here, if we want to test this as this, so remember this is your x, this is your y. And so here, if we want to show this as a solution, all we do is plug it in. So here for equation 1, I'm going to have 3 times minus 2 plus 3 equals minus 3. So, and we put a little question mark if we don't know. And so we crunch through this, we get minus 6 plus 3 equals minus 3. That's true. And then 2. We'll just plug this in here. So we'll have minus 2 times our x will be minus 2 plus 2 times our y, which is 3. Does that equal 10? And here we'll get positive 4 plus 6 equals 10. So that's correct. And so a solution, so the ordered pair, so we have x. So we plug x into the x and y into the y, and we get our solutions out. Okay, so the first method, which I asked the other class, and they said most of you've seen this before, but I'm going to teach it as if you haven't, right? So solve one. So it's a substitution method. So basically, you solve one of these equations for one of the variables, and then you substitute that into the other equation. You get an equation with only one variable. So in this case, we're going to solve for y. And then I'm going to put everywhere I see a y, I'm just going to put in what I solve for. And then then becomes an equation of one variable. You solve for that, and then you go back to the other solution and do that. It's actually kind of easier shown than explained. So let's do this. So here we're going to call this equation 1, this equation 2. So I'm going to solve 1 for y. So I'll have y equals to 1, and I'm going to just move over the 2x. Okay, so I solve this for y. Then I'm going to plug it into equation 2. So here would be 3x plus 4. What is y? Well, y in this case is, I know it to be 1 minus 2x. So I just substitute that in for here, equals 14. So it'd be 3x plus 4 minus 8x equals 14. This comes together to be minus 5x, minus 4 from both sides. I get minus 10, or positive 10, so x equals to minus 2. So once I know x equals minus 2, I plug it back into 1. So I'll have y minus 1 minus 2 minus 2. So that means y equals 5. And so here I have the solution of 2 comma 5. And you can easily check that. So 2 times negative 2 plus, so that's negative 4 plus 5, does that equal 1? Yes. 2 times negative 2, it'd be minus 6 plus 20. 4 times 5, does that equal 14? Yes. And so this answers both of this. All right. So go ahead and give B a try. So try B on your own and see what solution you get, and just put that into chat, and I'll be back in 1 second. So give B a try. So I'd probably solve the first one for y, which is probably what I would do. And then plug that into the second one and pop out an answer. And once you have an answer, put it into chat. Did anyone get an answer for it? Okay, we got some answers. All right, so let me go through it. So what do we do here? So we're going to just take 1. We're going to solve it for y. So I'll have y equals minus 3x. So just moving the negative 3, moving the x over. I'm going to plug that into 2. So I'll have minus 2x plus 2. And grab this, chuck it right in here. So minus 3x. So we substitute in. Once we do the substitution, here we'll have minus 2x minus 6 minus 6x equals 10. So we move the 6, so this becomes minus 8. X, move the 6 over, equals 16. So we have x is equal to minus 2. And then we go back to the first equation. So I have y minus 3, or y equals to minus 3 times minus 2. That equals positive 3. And so here I get minus 2, 3. Oops. Let me write that so you can read it. Rewrite so you can read it. Minus 2, positive 3 is our solution. Okay, so this is substitution method. It's usually the first method you see when you try to solve a system of equations. So let's go to the next one. I think I sneeze every class, don't I? Thank you. I must be allergic to math. All right, so elimination method. So elimination method is you make one of the variables the opposite of the of one of them. So in one of the equations, so if this is 2, you make this net minus 2, right? If needed, you multiply to make this occur. In each one of these, I guarantee you have to, I force the multiplication to occur. That way, you can see that done lots of times. You add equation to eliminate a variable and then do the same thing we did before. So let's just go through it. All right, so here we have 1, here we have 2. And so, not substitution method, this should say elimination method. Solve it using elimination method. Okay. Yeah, it's good now. All right, so in this case, I'm gonna leave equation 1 alone. So I'm just gonna rewrite equation 1. Just gonna leave it alone. But in order for our elimination method to work, I'm gonna take equation 2 and multiply by 2. Why? Because if I multiply everything by 2, I'll have negative 2y here, and when I add this up, it cancels out. So I usually write 2 times equation 2. So that's just usually how I write it. So it'll be 2x minus 2y equals 4. Does everyone see where I get this from? Everyone see where I get that from? Yes? No? As long as you see where I get this from, the rest of it really just falls out. No response. Okay. Why I use 2? Yeah, sure. Here, when I add this up, I want something to disappear. And since I have a 2y here and a negative y here, I think the easiest thing for me to do would be to multiply by 2. And if I multiply by 2, I get 2x minus 2y plus 4. And so when I add them up, I'll get 5x here. I'll get 0y here by design, and then I'll get 18. Oh, it looks like you're multiplying by, it's 2 times equation 2. That's what it is. Okay. Isn't it? Oh, yeah. And let's just tackle this before we finish answering all this. So let's look at this one. let's look at this one. Let's actually just do this all at once, and then we'll solve. Once you get to here, it's just solving. So let's look at this one. Here, I have a positive y, and I have 2 and 3. So these are not only not the same, but they're not even multiples of each other. So here I'm like, I don't want to do this, right? But here I have a positive 1y and a positive 4y. So I'm probably going to take, so my preference here would be to take this equation. I'm going to write minus 4 times equation 1, right? And if I do that, I get minus 8, minus 8x minus 4y minus 4. And then here I'll just keep equation 2 the same. So I get 3x plus 4y is equal to 14. And then when I add this up, I get minus 5x, 0y equals 10. And in fact, let's just, as long as I'm just doing this step first all the time, let's just show you all the answers, and then we'll finish solving these in a second. So let's look at this one. So here, I don't have anything that's a multiple. So I have 3, and I have a 2, and I have a 2 and a 5. And so nothing jumps out as a good answer. And so in this case, sometimes you just, if nothing's good, you can always just say, let's get rid of x this time. I got rid of y the last 2 times. I'm going to multiply this one. Let me be consistent here. I'm going to multiply this one by 2, right? And so I'm going to say 2. So I'm just going to take this one here, and I'm going to multiply by the first equation. So 2 times 3. Oh, no, 2 times equation 1, right? And then I'm going to take this one, this coefficient, and I'm going to negate it and multiply it by 2, the equation 2. And when I do that, notice what I get here. 2 times this equation will give me 6, x plus 4y equals 10. And then negative 3 times this equation will give me minus 6x minus 15y equals minus 21. And when I add these two up, the x's cancel, right? And so we just want one variable to cancel. And so here we get no x's, minus 11y, and then minus 11. Okay. And then let's look at this one and just finish our thought here. Notice here I have two y's here and then a y here. And so your inclination would be to multiply this one by -2, which is perfectly fine, right? But also notice that everywhere this is 2. And so I can factor out a 2 here and just make my number smaller. And so if you multiply equation 1 by 2, or -2, you'll get, it works out. It just works out fine. But since I don't like to think in large numbers, I'm going to multiply equation 2 by a half. By a half. And the reason is because the -half easily comes out. So I'll have 3x, I have 3x here plus y minus 3. And then here, half, this becomes positive x minus y minus 5. And this is just smaller numbers. Now, 90% of you will not do this. 90% of you will do -2 times that one, right? But just for flavor, I'll show you this also works. We add this up, I get 4x equals -8. And so that's the bulk of the substitution method. Once you get to here, it's just the elimination method. Once you do the eliminations, you get back to this point. And once you're to this point, since we're here on every one of these problems, it's the same as substitution. You solve for the given thing. So this one, let me save this one. This one's actually ugly. let's do C next, right? So here, x is equal to -2. So we solved for the clean one, and then we just plug it into one of the equations. So I'm just going to plug it back into here, right? So it'd be 2 minus 2 plus y equals to 1. That means y equals 5. And so here I have -2, 5 is my answer. Here, for this one, I get y divided by 11. I get y equals to 1. I'm just going to plug it back into the top one. So 3x plus 2 times 1 equals to 5. Well, that means 3x is equal to 3. That means x is equal to 1. So I have the solution 1, 1. Okay. Let's do this one, which ends up not being clean. I should have probably saved it for later, but so this means x is equal to 18/5. I just plug it back into one of these equations. And so I'm going to plug it back into this one just because it's the simplest, right? So in this case, I'm going to plug it back into the second equation just because that one's the easier one to deal with. So I have 18/5 for my x minus y equals 2. That implies, I need a little bit more room, y equals 18/5 minus 2, which means y equals 8/5. Yeah. Come on. 8/5. And so we already have 18/5, 8/5. And so it's just not as clean. And then our last one here. So notice once we get it to this point, we add it up. We get 4x equals 8, or x equals 2 minus 2. Actually, here, no, that's fine. X equals minus 2. And then once we just plug it back into this one, because that's the easiest one. So at 3x minus, or plus a negative 2 equals minus 3. Hold on. That's an x. I plugged that in the wrong spot. There we go. And then we solve for y. We get y is equal to positive 3. Because this is minus 6. Move the 6 over, you get positive 3, so we get minus 2. Okay. So the bulk of elimination method is just figure out a way to multiply one equation by another. Sometimes you don't have to. Like sometimes do I have one of them? Gee, I didn't make anyone where you don't have to directly. And so you just you figure out if I multiply one equation by some variable, and sometimes you'll have like x plus y equals 3, and then you'll have x minus y equals 2. Sometimes you'll have it this simple, and when it's this simple, you can just add them up directly. You get 2x equals 5, and so x equals 5 halves, and then you just plug it in and figure out what the other one is, right? So sometimes you don't have to multiply. Sometimes you can just add directly. But most of the cases you'll have to do some sort of multiplication. So I wanted to show you a couple of versions of that. So here I had a positive and a negative, and so I just multiplied by 2 to make those to have the same coefficient, just one being negative. And so I get this. Here I had a positive and a positive, but these two didn't match, and so I multiplied this one by a negative of that coefficient to get this to come out. For here, nothing really was nice at all, right? It really wasn't. And so what I chose to do in this case is to multiply, I was going to get rid of the x, and so I was going to multiply one of them by 2. So I multiplied the other equation by the coefficient on this one. So that's the 2. And then here, make sure one of them is negative. I did by minus 3 here. And so I get 6x and minus 6x. You know if you did the multiplication wrong or the elimination step wrong because you'll still have both variables. So just try again. And here, I figured I could just divide this by a half, or negative half. Oops, sorry, I forgot my negative half. It disappeared. And then I get it like this, and then I can just add them up, and we get it here. Okay. So that's how you do these. Give it a try. Some of you have done this before, some of you haven't. This is the step which gives you the most trouble, so I try to make sure to include lots of examples for that. All right, so, I feel kind of bad. Let me do one, because I did a part here, a part here, a part here, and a part here, and I never just did one all the way through. So let's do one all the way through. In fact, I'm going to do this one the other way, just so you see me work a problem from start to finish, right? So let's do it the way you would do it. You'd probably do -2 times equation 1. Why? Because that would make this one -2 and go across. So this would be 3x minus 2. Oh, no. This would be, hold on. This would be -6x minus 2y equals +6. And then I'd have -2x plus 2y equals, because I'm just going to leave equation 2 alone, 10. If I add this up, I get -8x equals 16. So I have x is equal to -2. And then if I have x equals -2, I'll just plug it back into here. So I'll have I have 3 times -2. So I'm plugging it back into this equation. Y equals -3. And then we'll get the same thing we got before. Y equals 3. And so we have the same solution. So that's one problem seen start to finish in a direct manner. Okay. All right, so let's talk about graphing method. Boop. All right, so here the graphical method will graph all the lines and we find the intersection lines. I'll show this in a second. Let me finish this page of notes and I'll open up Desmos and show you exactly how to do this. So number of solutions for a linear system. So a linear system can have exactly one solution. If it has a solution, right, it is called consistent. So it's called consistent. Oops, there's another S in that. So it's called consistent if it has a solution. So these two are consistent because they have solutions, and this one is inconsistent because it doesn't have a solution. And then for the equations, if one's a multiple of another, we say it's dependent. And so this, you'll see that here, that this is a multiple of this one, aka this is -2 times this equation. And so we say the equations are dependent. So here it's the system. The system is consistent, right? And the equations in this case are independent. If there's only one solution, means one's not a multiple of the other. And this one is dependent, meaning one is a multiple of another. Okay, I just forgot to specifically give you those vernacular in the notes. So it can have one solution, can have no solution, or can have many solutions. So the best way to kind of look at this is graphically. So if a system has one solution, whoop, not what I wanted. You'll have two lines, and they'll intersect at some point. And whatever that point is your one solution. A system that has no solutions will have the two lines will be parallel, right? And so since these are parallel, these will be parallel lines. They'll never intersect, and so there is never an intersection, so there is no solution, right? And they can have infinitely many solutions, and what that looks like is that we have both lines are the same. Both are the same line, I guess I could write it that way. Both are the same line. And then we have an infinitely many solutions. So let me show you that in practice. And then we'll show you that using the graphs. All right, so here in practice, if I'm doing this, I'm going to just try to solve this. And so if I just solve it, just doing what I want to do. Hold on. My brain went fire. Here we go. So here, I'm going to get rid of my y, right? I'm going to try to get rid of my y. And so here I have a 3, I have a 2, so I'm going to multiply this one by 3, and this is a -2. So I'll multiply this by just 2. So that should give us positive negative. So here it'll be 3 times the first one times 2 times the second one. And that should clear out a variable because here I'm just trying to clear this out. And so here I get 24x minus 6y equals to 15. And then here, if I multiply this by 2, I get minus 24x minus 6 or plus 6y equals 14. And so here I've done what I've decided to do is get rid of my y. But notice what I've also done here. I've also gotten rid of my x. And so here this is 0, right? This adds up to be 0. 24x minus 24x is 0. 6y minus 6y is 0 equals 29. So if you have 0 equals a number, this is never true, and so this is no solution. And so we would say this system is inconsistent, right? Now for this one, we're going to do the same thing here. So notice I have let's get rid of the y's. I'm used to getting rid of the y's, I guess. So here we have a 4 and we have a 2. So I just need to multiply by this by 2 and I'll get a minus 4. So I'm going to take equation 1. I'm going to multiply it by 2. And that gives me 8x minus 4y equals 12. And then here I'll have 2 equals minus 8x plus 4y equals minus 12. If I add this up, I'll get 0, 0, and 0. I get 0 equals to 0. I noticed, and so this is always true, right? And so this has infinitely many solutions. And so this has infinite solutions, infinitely many. Which sort of spelling infinitely terribly. We're just going to write infinite solutions. Ta-da! And what are the solutions? Anything along this line is a solution. So we'll solve one. So we're just going to solve this one for, we'll just solve one of these. And so we'll just solve the first one. So we'll have 4x minus 2y equals 6. So that means minus 2y equals minus 4x plus 6. So I have y equals 2x minus 3. And so my solution set here is x, 2x minus 3. Okay, because for whatever value you give me for x, I can give you a value of y, right? And so this has infinitely many. So if I give you 1, if I give you a 0 for x, I have the value of negative 3 for y, and that solves this equation. And if I put in 1 for x, I'll have negative 1 for y, and that solves this equation. Okay? But notice that this equation and this equation is just, if I multiply this equation by negative 2, I get back this equation. And so this is consistent in the sense we have a solution, in fact, implemented. But these are called dependent because this is a multiple. This equation is a multiple of this equation. And that's why it's called that. All right. So let me show you graphing. All right, so let's graph this puppy. No, stay on the page. All right, so let's graph. So let's do this in the order that we've kind of seen it. So let's graph this one right here. Okay. And so here, if I graph these two lines, sorry, I have it pre-typed in. So here we have 2x plus 2y equals 5. We have this line, and then we have this one, 2x plus 5y equals this. And so if I graph these are the lines I get. And here, notice the intersection is 1, 1. Well, that's our solution, right? That's our solution. Let's do, I don't know, this one. Let's just do this one real quick. So I have 2x plus 1 equals 1. Oops, plus y equals 1. And then here I'll have 3x plus 4, y equals 14. And so I get two more lines. Where does this cross? At 2, 5. Is that the solution we got? Yes, it is. And so here, this is graphically, you just graph the two lines and find the intersection. So let's do these ones. Let's look at these ones real quick. Click the right button. Hi, come back. Where'd you go? Come back. All right, so let's look at this one real quick. So here we have 8x minus 2y equals 5. Whoa, what happened here? That did not go as planned. All right, so we have that line, and then we'll have minus 12x plus 3y equals 7. And so notice how these two lines are parallel. No matter how far we zoom out, they never cross, right? And so this means no solution, right? And that's what we got here. And then for the last one, we have 4x minus 2y equals 6. And then here we have minus 8x plus 4y equals minus 12. Oh, ta-da. All right, so we have this. And so notice that these are the same line, right? They're the exact same line. So they're on top. So anything along this line is an answer, right? And so that's why, and so you just solve, and so in that case, you just solve one of them for y, and then you have the solution of x, and then whatever your y is. Honestly, when I do this in all my other classes, you usually set x equal to some t, and then you solve through, and then you get the solution t 2t minus 3. But your book just likes to leave it as x. I like to swap the variable, just what I was trained to do, just my training. Okay, so let's do, in the last 10 minutes, our 2 word problems. So let's do 2 word problems. Let's do one from the book, and the one I gave you guys, and one from the book. And that way you've seen everything that you probably need to see. All right, hi. Mouse me, thank you. Whoop. Okay. So what are system equations useful? Well, it's useful for solving real world problems. I mean, this is a little bit make-believe, but a woman rows a boat upstream to a point 4 miles away in 1.5 hours. The return trip, she's traveling with the current, right? And it takes 45 minutes. Assuming the current and the rowing occur at the same speed, which is pretty about how fast is the woman rowing and how fast is the current. So we're going to say R is how fast she rows, right? So this is how fast she rows. My computer's getting crunchy. No, don't get crunchy. I'm going to say C. Oh, come on. Let me see if I can clear off some stuff real quick. Yeah, go bye-bye. Let's get rid of tech. Let's get rid of this. Can't get rid of Zoom. My iMovie's still open. That definitely can get closed. Let's close this. And yeah, okay. Yeah. All right. Are you less crunchy now? No, you're still super crunchy. Hold on, let me save this file, export as PNG. You just clear memory. Yeah, don't save. Bye-bye. File export as PNG so I can have copies for later. Sorry, I'm trying to make it less crunchy. That way it writes. There we go. Okay, so this is the rate. Oh, see how it writes now? It's the rate of rowing. So this is how fast she's rowing. We're going to let C be the rate of the current. So this is how fast the current's moving. And so let's write our little things. And so we're gonna put everything in minutes just to make our life easier. So 1.5 hours will be 90 minutes. So in 90 minutes with her, she's rowing, but she's going against the current. She makes it 4 miles, right? And I want to know miles per minute, I guess, right? And then here, it only takes 45 minutes when she's going with the current, right? So her rowing speed plus the current equals the 4 miles, right? Um, so so here we can just solve the system of equation, and we'll get and just because our rate equals distance divided by time, and so here I have my time times my rate gives me my distance, and so here we get a solution, a system of equations. And so once we solve this, and I won't solve it just because of time, you can crunch the numbers, right? Basically, the easiest thing to do is just write this as R minus C is 4 over 90. And then R plus C is equal to 4 over 45. You add the two up, because here we can just add it directly. I get 2R equals 4 over 90 plus 4 over 45. Those don't add up, super simple. But you get actually, once you solve this out, you get the rate equals to 1/15th, right? So 1/15th of a mile, 1/15th, remember that? And then you solve for C, and you get C equal to 1/45th. And so that's miles per minute. And if you want, you can multiply by 60, and you'll get 4 miles. You'll get 4 miles per hour, and then you'll get whatever this one ends up being. So that's how you solve that. But I'm not too worried about this one. I want to do the other one. So let's do the other one here on space. And this is something from your homework. And they just love asking these questions. And so the first one is, it says basically you invested $7,000 between two accounts, right? Between two accounts, where the first account gives you back a 3%, has a 3% return rate, and the second account has a 9% return rate, or 9% annual interest. Annual interest, and it says you earned. Hold on, I can spell earned. $510. Okay, how much was invested at each rate? So how much was invested at each rate? And so it wants to know how much did you put in the first account and how much you put in the second account. So you said you split in $700,000 between the two accounts. I don't tell you which account. I put X amount of money into it, right? And overall, you earn $510. And it says, well, how do you find that out? Well, the way you find this out, and I use substitution method, right? So I know that, let's just call this account X, and we're going to call this account Y. So the amount of money I put, let's just do this, is X is the amount of money I put into the first account, right? So it's the first account. Let's write the amount in the first account, and Y be the amount in the second account, okay? So you have $7,000 you put into account. One's at 3, one's at 9, and you've earned 512 interest. So the way you figure this out is that if you add up both accounts, that's all your money. So that was $7,000, right? Or that's $7,000. So X plus Y needs to be $7,000. That's one part. The second part is that 0.3 or 0.03 times X is the amount of interest I've earned in the first account, plus 0.09 times Y is the amount of interest I've earned in the second account, depending on how much money I put in. That needs to equal $510, right? And so this is just nothing more than a system of equations. And so what do? I use substitution, right? I solve Y is equal to 7,000 minus X. And so here I'll have 0.03 X plus 0.09. And then I'll just substitute this in. 7,000 minus x equals 505.10. And then, honestly, I just have Wolfram Alpha solve it. So let's just do is what I'd honestly would do. Here we go. Just bring this up. Hi, Wolfram Alpha. We're no longer solving logic equations. And so here we just type in 0.03 times x plus 0.9 is 7,000 minus x equals 510. And we get x is 2,000. So if x is 2,000, so we get x is equal to 2,000, well then y must be 5,000. Okay, so that's how you solve that one. These are common, and we do them all the time. All right, so that's how you do this one. Let me just show you the homework real quick. And for the little star, that's where I'm going to crop this off. Let me show you the homework real quick, and we'll call it good.